Saturn is the most beautiful object in the solar system. Every astronomer who sees it through a telescope for the first time stops. Just stops. Because nothing prepares you for the rings. Perfect, geometric, impossibly elegant. A planet wearing a crown of ice and rock stretching 282,000 kilometers wide, but only 10 meters thick in places. Now imagine, that planet is gone, and Earth is there instead. 1.4 billion kilometers from the Sun, wearing Saturn's rings, surrounded by Saturn's moons. What happens to us? Before we continue, your question for today. If Earth replaced Saturn, would Earth's gravity be strong enough to keep Saturn's rings in place, or would they collapse? Drop your answer in the comments. Most scientific answer gets pinned. New here? Subscribe now for more. Saturn sits 1.4 billion kilometers from the Sun, 9 times further than Earth's current position. At that distance, Earth receives just 1% of the solar energy. The Sun from Saturn's orbit is just a bright star, barely distinguishable from the others. No warmth, no light worth mentioning. Surface temperatures plunge immediately. Within years, minus 150 degrees Celsius. Within decades, minus 180. The atmosphere begins to freeze. The oceans solidify completely within a generation. Everything that makes Earth alive, the water cycle, the weather systems, the seasons, stops. But here's where Saturn's orbit is different from Jupiter's. It's not just colder, it's darker. At Saturn's distance, the Sun is a point of light, like a lighthouse seen from the wrong side of the ocean. But now, the extraordinary part. Saturn's rings. In this thought experiment, Earth inherits them. Is one of the most visually spectacular scenarios in science. Saturn's rings exist because of Saturn's Roche limit, the zone where material prevents from clumping. Earth's gravity is weaker than Saturn's. The outer rings, beyond Earth's Roche limit, would immediately begin clumping, coalescing, forming moonlets, growing larger over thousands of years. But the inner rings would stay as rings. Seen from the frozen ground, they would fill half the sky, a permanent, tenuous arc of ice. Now here's where this thought experiment becomes genuinely important. Saturn's moon, Titan. It's the only moon with a thick atmosphere, nitrogen-based like Earth's. It has clouds, rain, lakes, and rivers and seas, not of water, but of liquid methane and ethane. At minus 179 degrees, methane does what water does on Earth. It evaporates, forms clouds, rains down, flows in rivers. Titan shows us that the living world, weather, cycles, liquid on a surface, doesn't require water or warmth. It just requires the right chemistry at the right temperature. And then there's Enceladus, seemingly unremarkable, until 2005, when the Cassini spacecraft flew through enormous geysers of water vapor erupting from its south pole. Tidal heating from Saturn's gravity keeps Enceladus's interior warm. Beneath its frozen surface, a global liquid water ocean, with hydrothermal vents on the ocean floor. In a world where Earth sits frozen at Saturn's orbit, Enceladus becomes the most important object. A small, icy moon hiding a warm ocean that might already contain life. We define habitability by what we know, Earth's template. But the universe doesn't use Earth's template. It uses chemistry, energy, time. Saturn's rings are disappearing. In 100 million years, they'll be gone, pulled inward by Saturn's gravity. And tonight, if you look up, you can see Saturn, a steady, pale gold point of light, carrying its secrets. In the darkness, somewhere in that darkness, there may be an ocean, warm, liquid, alive, waiting for us to arrive. The universe is far more alive than we know.